Hey, ladies and gentlemen, so today what we're going to do is we're going to be talking about the square root function. So here's our square root function. It's actually the inverse of our quadratic function, or that y equals x squared function. And so we're going to look at the different transformations on this function. So again, if we've noticed, we've kind of seen a pattern. So the transformations for our absolute value function and the transformations for our quadratic function, as well as our exponential function, have all been basically the same. The parameters are treated like do the same things to the function. So we're just going to kind of show that here again. So if a becomes bigger than 1, you can see that graph gets a little bit higher, so we call that a vertical stretch. If I go in between 0 and 1, like a 0.7 or like a 2/3 or something like that, you notice the graph gets a little bit lower, so we call that a vertical shrink. If I make it negative, it flips it across the x-axis. And if you have a negative and a number, then you have two things going on. You have the reflection plus the vertical stretch with that. All right, let me go change this back to 1. So when h and k are 0 and a is 1, we have our parent function. This is just our y equals your square root of x. And so if I move my h to the right, the slider to the right, that means my h value is positive. But remember, up here we have an x minus. So this means I have an x minus 4.4 as far as my equation goes. And so when I have an x minus, my graph goes to the right. When I have like a negative 4.1, that changes. If I were to substitute in a negative 4.1 in for h, I end up with an x minus a negative, which changes it to an x plus. So when I have an x plus h, that means my graph goes to the left. And k, make it positive, it goes up. When I make it negative, it goes down. That one does what we think it should do. Now, all of our functions up to this point have had kind of like an inflection point or some kind of point in the middle. So with your square root function, it's just this point right here is 0, 0, and that's like your h and k value. If I were to change my h value and my k value, now my new point here, or my starting point, is at 3.3, negative 3.5, and that matches the opposite of what we'd see up here and keeping that the same. Now, our domain for our square root function, we can't take the square root of a negative number. So that is why our square root function starts here at 0, 0. We can take the square root of 0, but we can't take the square root of negative 1. It's not a real number. Now we can make our function go all over the place by transforming it, however. All right, so let's go ahead and put some things into our notes. Now, so our parent function is y equals our square root of x. And when I graph it, so if I were to do an xy chart, remember I can't put in negative numbers because we can't take the square root of a negative number, or at least not until you get to algebra 2 when you're introduced to a whole new number system of imaginary numbers. So I'm going to start with 0, and the square root of 0 is 0. The square root of 1 is 1. Now I'm going to skip a few numbers here. I'm going to look at just perfect squares. So my next perfect square is going to be 4, and that's going to be 2. And then my next perfect square I'm going to look at is 9. And the square root of 9 is 3. So when I graph this, I get 1 or 0, 0, 1, 1, 1, 1, 2, 3, 4, 2. And here we go. I'm a little bit off there, but that's okay. And then, oops, and connect it with like a little bit of a curve. And that's what our parent function of our square root function looks like. It's a slowly increasing curve. So it is still increasing and going up. It just goes up really, really slowly. Alrighty, so here we go with our transformations. The a value, again, if we have a negative a, that means we have a reflection across the x-axis. When we have an a value that is bigger than 1, it's a vertical stretch. And when A is in between 0 and 1, we call that a vertical shrink or a vertical compression. I tend to use shrink a lot. A lot of our notes in our books call it a compression. When we have x minus h, that just means we are going to the right, h units. If we have an x plus h, means we are going to the left, h units. And I know that seems opposite of what we normally think, but I kind of explained a little bit in that other, when we use Desmos, as to why that happens. So plus k does what it's supposed to do. So plus means we are going up, and minus means we are going down. So it kind of messes with your inputs. And so when you mess with your inputs, it goes opposite of what we would think. The k value messes with our outputs or our y values. So it makes sense that if we were to add a number to the y values, it goes up. If we subtract a number from our y values, it will go down. Let's look at some examples. Alrighty, so here we've got a few things going on. We have this negative, so we have the negative, we have a 3, and we have that plus 4, which means we have 3 transformations happening here. So the negative means that it's a reflection. The 3, since it's bigger than 1 and it's an A value, means that it's a vertical stretch. We don't have an H value. Now, in this case, your H value is going to be put underneath your square root symbol, which is kind of the equivalent inside the parentheses for a lot of our other functions. It's just another set of grouping symbols. So there is no H value, but we have this plus 4, which is outside of that square root symbol, which means since it's a plus 4, it means we are going up 4 units. The second one, so if we look here, we only really have this minus 1. We don't have an A value. We don't have any numbers underneath that square root with the x, and so we just have this k value. Since it's a minus, when we have a negative k value, it means that we are going down 1 unit. The third one, I do have an A value. Since it's between 0 and 1, or it's a fraction, we know that this means it's going to be a vertical shrink or compression. Now that plus 6 is now underneath the square root symbol, which means it is an H value. So it's messing with the X value, not with our Y value. So since it's X plus 6, if we kind of think back to our previous slide, X plus H meant that we were going to the left. So this is going to be a left 6 units. Last but not least, we have this number 4. It's doing a whole lot of things. We have a negative, we have an A value, we have an H value, and we have a K value. So I feel like I'm going to probably just do a little squiggle here. Oops, went too far. And I'm going to kind of start way over here. Alrighty, so that negative means that we have a reflection across the x-axis. The 4, since it's bigger than 1, means that we have a vertical stretch. Oops. Now this x minus 2, since that minus 2 is underneath your square root symbol, that's an H value. So x minus means that we are going to be going to the right 2 units. That minus 8 is on the outside of that square root symbol, so it's a k value. So it means that we are going down 8 units. Alrighty, so that's it for transformations of square root functions. If you have any questions, please make sure you message me.